thermal. So welcome to this Zeroth law of thermodynamics. Now we know the concept of thermal equilibrium. When we talk about thermal equilibrium, we know that if system A is in thermal equilibrium with system B, then there is no exchange of energy, no exchange of energy with respect to time. So if we take infinite amount of time and if we measure, then we will see that this too has no change. That means it is in thermal equilibrium. Now, say suppose I take another system which is in thermal equilibrium with B, system C. So I know B and C has no exchange of energy and therefore these two are in thermal equilibrium. So the zeroth law of thermodynamics tells us if A and B is in thermal equilibrium and B and C is in thermal equilibrium, then we know that C and A is also in thermal equilibrium. Thermal equilibrium. So this is what the zeroth law tells us. Now, why is this important? The reason this is important because zeroth law of thermodynamics leads us to the concept of temperature. That this tells us as something about temperature. What is actually temperature? So if there is no difference in temperature, then there will be no exchange of heat. So this is what was the first understanding of temperature. Now, with temperature comes your other terms like internal energy and work done. Internal energy and work. So now let's take a example. Let's take a physical example to understand this. Say suppose you are moving this object to a height of mgh. This is your reference point and you are moving this object over here to a height h. So you are doing work and you are placing this object to a height h. That is, you are giving this object, by doing work, you are giving this object a energy, that is a potential energy. You are supplying potential energy to this object. Now it has moved a distance of h. That is, you are doing a work. Now after that you are away from the system. Say suppose you move away from the system. So now the object is at mass m. The object is at height h and this is its mass. So now it will fall down. That is, it is also doing a work. That is, there is a force of gravity. And a displacement is being done. That is displacement along the negative y-axis. So we know work is nothing but your force into displacement dx. So if no one is present, then a work is done. That is, along with the direction of force, this is being done. So what changes? Now this energy is converted into another form of energy, that is your kinetic energy. So now you can see this is a change in kinetic energy. That is, there is an internal change in energy with relation to work done. With relation to work done, there is an internal change in energy. So this is how we can relate. I just gave you an example how energies can be interchanged. So let's have a look at what actually is internal energy. So now if we try to define internal energy, we can understand it this way. There are numerous molecules in an object. Now if this object is placed at a height h with relation to a reference frame, if this is my reference frame, then it's placed at a height h. So all these molecules have some mass m, and therefore it will have some potential energy mgh, mgh, mgh. And plus also there is motion of these molecules or electrons, or say suppose in an object motion of particles. So if there is a motion of particles, what you can say is that there is also a kinetic energy. So because of the position of this object with respect to your relative frame or reference frame, this object has an internal kinetic energy and potential energy. This is how you can understand the energy or internal energy. And internal energy is defined by the symbol U. U tells us about internal energy. So now, when a certain amount of heat is supplied to the system or a certain amount of work is done to the system or with the system, then there is a change in internal energy. There is a change in internal energy. Now we come to another concept. If there is an external force that has been acting or external work done, say suppose there is an external work done, then there will be no change in internal energy. But if there is no external force and this system does work, then this system is doing work by spending its own internal energy. By spending its own internal energy. So this is what we come to conclusion. This is what we logically derive. So if there is external agents that is acting in moving this object, then there is no change in internal energy. But if this object or this body is moving without any external help or force, then it is using its own internal energy.